education. This is, you can say, the transformation, because the students are the peoples who are developing or who are growing up in this digital era where internet is available everywhere, where you can find the digital devices. Therefore, their behavior totally dependent on them. A student can access immense amounts of knowledge through different mediums, spending an average of 6 hours a day on electronic media. Students in the 21st century can no longer be restricted to traditional learning methods, which are commonly used in universities. Basically, this is the transformation, learning transformation. If we remember that on PTV, I think Allama Iqbal Open University was the first university who introduced this distance learning program. And on the PTV, they show the recorded lectures. So they started from that, the distance learning can be started when it was completely digitalized, then the e-learning, and then the m-learning, mobile learning, and nowadays on the pervasive learning. In e-learning, you have the right time, means data was available, and you have, if you have the any right time, you can access the data. But when it was in mobile learning, the right time and the right place, the students, uh, this opportunity was provided to the student that whenever you want to study, you can access the data. But when we are coming on the pervasive learning, the right time, the right place, the right device, and the right way. Means right way means in any format, text, video, or image, or in any format. Right device means the mobile devices or the laptop or any other devices. You can see others that in e-learning, computer networks were used, and mobile learning, mobile devices, and wireless communication, and context-aware e-learning, sensor technologies, mobile devices, wireless technologies. So this is the learning transformation, and smart education is not a fantasy in the 21st century. Rather, it has become a reality worldwide. The learning form is gradually promoted from e-learning to m-learning and now to pervasive learning. Basically, this is the environment of the pervasive learning. Pervasive learning is the new form of the innovative technology used in the educational system. It can help a student to acquire knowledge by anyone from anywhere at any time and with any mobile or handheld device only when he or she willing to learn. Pervasive learning uses intelligent features that make the user aware of the content, provide an atmosphere that enhance learning. The system supports learning with the user is on the move by using variety of devices. It provides flexibility for a student to manage the time for learning and professional work. It reduces the travel and printing expenses. It also saves the travel time. Basically, pervasive learning is to facilitate those students who have to do the job, who have to support their family, because if they are not doing the job, definitely their family will suffer. So in parallel, they have to, through the pervasive learning, they have the opportunity to continue their study, and in parallel, they can do the job. And this also to facilitate the disabled person or the persons who take the accident or any thing happened to them, and they have to take in 6 months or 1 year or 2 years bed rest. And in this period, most of the students have to break from the study, but through this learning environment, they can continue. And you can see enable lifelong learning. They access anywhere and anytime. You can access when you are in the office, when you are in a bus, when you are in a bed, or when you are in a university. And then you
की साइड में कोई इशू लग रहा है अनम्यूट ही है ना?
अनम्यूट
ऑन है माइक? हेलो डॉक्टर याकूब साहब।
फिल हो गया उनका सिस्टम, आपको ज्वाइन किया गया।
है कॉन्टैक्ट नंबर तो मैसेज ड्रॉप कर देंगे तो।
नहीं तो फिर ये बात
अस्कर भाई वेलकम। अभी माशाल्लाह आज टॉप दे रही हैं।
अस्सलाम वालेकुम। ये रात को डॉक्टर वालेकुम सलाम डॉक्टर साहब, ये डॉक्टर सगीर साहब की ना मेहरबानियाँ हैं। रन टाइम पे कहा कि बस टॉक दे दें, और यहाँ पे कॉन्फ्रेंस चल रहा है, वहाँ पे चेयर भी हूँ, बस इन्होंने कहा कि बस किसी जनरल टॉपिक पे दे दें।
आपका माइक कौन है?
ओके। आवाज़ आ रही है?
Hello.
जी याकूब, डॉक्टर याकूब साहब।
Sir,
जी
I
सर।
think I have an internet issue right now because of the light. So now I am logging on my mobile.
Oh, okay, sir. No issue. If you are in trouble, no issue. We can proceed with the next guest speaker.
Yeah, then I will join you again.
Okay.
And in the meantime, I will share with you these slides with you. You can share with the others.
Okay. Okay. Thank you, sir. Thank you.
Thank you. Thank you very much, sir, once again.
Your
डॉक्टर अदनान साहब।
अस्सलाम वालेकुम जी सर।
Sir, kindly start your talk on dynamic application of weighted federated machine learning in smart city.
Sure sir. Just a minute. Okay sir.
Sir,
My screen is
sir.
yes. Should I start, sir?
Sir, just 1 minute for introduction.
Okay, okay.
Machine learning in smart city environments. Muhammad Hassan Khan, senior member IEE, is a highly accomplished researcher and academic. He holds a PhD from psychology and clinical data professor at Graduate University in South Korea, as well as an associate professor at Horizon University, Kuala UAE. With 16 years of teaching experience, he supervises multiple PhD and research scholars and has also over 300 research papers and impressive publications factors of more than 700. Dr. Khan has earned several Best Researcher awards and has been recognized by Stanford University as one of the world's top 2% impactful researchers for 3 consecutive years. He also serves on editorial boards of leading international journals and actively contributes to global conferences. His research spans computational intelligence, machine learning, medical diagnosis, image processing, and advanced communication systems.
Yes, Dr. Nan, please proceed.
Assalamu alaikum to everyone, especially Dr. Nadeem and Dr. Shahan, who's chairing this session. And the today topic is dynamic application of the weighted federated machine learning in smart city environment. Okay, my voice is clear?
Yes, sir.
Okay. Okay, just I give the brief introduction about me regarding my research journey. So far, I have published more than 350 articles, and my cumulative JCR prep factor is 1100 plus. And this is just citation information in Google Scholar. I have more than 14,000. Similarly, in Web of Science, more than 5,000. H-index is 41, and so on. Now we move towards our today's session. Okay. First of all, we discuss what is a federated learning. After that, we discuss weighted federated. It is a variant of the federated machine learning. Okay, federated learning is a way to train the models, AI model, without anyone seeing or touching your data. Federated learning is also known as the collaborative learning. That is a technique of the machine learning in which we train our algorithm across multiple decentralized edge devices or servers holding local data samples without exchanging them. Now I would like to explain the concept with the help of diagram, graphical visualization. Okay, in traditional machine learning, what's the difference between the traditional machine learning and the federated learning? In traditional machine learning algorithms, if we have a multiple clients, each client need to share their data to the server, and then we train the model at the server end. When every client want to share the data, it's made it consume bandwidth. It's need a lot of bandwidth. Okay, and bandwidth, we know that that is a not a unlimited, there's a limited, and we need to pay. So in federated learning, we say that we no need to share the data. In here, you see that there are 3 organizations that's known as the client 1, client 2, client 3, organization 1, organization 2. Each organization have their own data. In federated learning, we say that you don't need to share the data. You just train your model on your data and just share the trained model weights. Let's suppose if organization 1 have the 10 GB data, just like, and organization 2 has a 1 terabyte, and organization 3 also have the data. When they share the data, the privacy is there. Privacy concern is there because organization not want to share their data. So in this case, we said, okay, you just train your model and share the data weights, and weights just take in KBs, maybe a 1 KB file or 2 KB file. During that, we also save the bandwidth of the channel as well as, and we secure the data as well. And server end, just we get the weights of each local trained model, and we use some aggregate model, and which we use for the real-time application for the prediction purposes. So in server end, we use the federated learning. Okay, in here, the mathematical model is very important. So first, I would like to explain the mathematical model of the client side, which we use at organization 1, 2, 3, and then we discuss about the server side mathematical model, and then I will discuss about the few applications where we deploy, implement these mathematical model and publish our articles in. Even we also implement these algorithm in our funded project as well. So today I just discuss 2 funded project application where we apply these things. Okay, in client side, actually, you can use any algorithm. It's up to you. You can use GA, PSO, neural network, and so on. But in today's session, I include the mathematical model of the neural network. So in client side, we use the adaptive feedback propagation neural network. At server side, when we make the aggregate, I use an adaptive feed forward neural network. So in here, we know that when we're talking about the artificial neural network, it consists of the at least 3 layers. At least it can be more than that, but at least 3 layer: input layer, hidden layer, and the output layer neuron. Each layer contains the multiple neurons. Is the input layer also contain multiple neurons? It depends upon your problem, how many your independent variables. It depends on that one. So in here we use, you see that A shown that the client client A represents the weight between the teeth neuron of the input hidden layer and the F neuron of the hidden layer neuron of the ith client. And ST represents the input layer neuron, which is our independent variable. And C represents the bias. So in here we use the sigmoid activation function, and it gives the and one more thing, in here we use the sigmoid. It's depend upon your problem to problem, because my output is, when your output lie between 0 to 1, we can use sigmoid. If you can use the ReLU, tan hyperbola. It's depend upon your problem. According to your output, your mathematical model also changed. So in my problem, one of the problem that is a binary classification in which we use the sigmoid activation function, but in other problem we use the tan hyperbola and ReLU activation function as well. Then WCLI mean the client, that is the out of the hidden layer output of the F neuron, and then we need to calculate the out H, predicted estimated output, which is known as the X client of N. In here you see that the weight of the previous output of the previous hidden layer, that is the input of this neuron, WCLI of F, and BI again is the weight of the that layer between the F hidden layer and the nth output hidden layer, and then C2 is the bias of that layer, and then we compute the X of CLN, mean that is a nth layer neuron output of the client client. Then we need to calculate the error. This is the predicted value, and we also, because there is a training, we have the trained data as well. We know that is a supervised learning actually. Then we know the output data as well. So first we need to calculate the error. In here, F represents the error of ith client. In here, we can use multiple formulas of the error, but I use the minimum mean square error. You can use the mean absolute error and others formula, but in my I use the minimum mean square error, and your further mathematical model depend upon this error. Now, next, this is the feed forward, because in client side we use the train the model. When we train, the back propagation is play a very important role. With the help of back propagation, we train, we update the weights between the layers. Okay, so in here, change in A, change in B. Actually in here we apply the chain rule. A shown the weights between the input and hidden layers, that represents the matrix, and B represents the weight matrix between the hidden and output layer. Okay. In here, we can use the chain rule. After applying the chain rule, we simplify this equation, and when we substitute the values in these formulas, so in here you see that the third equation is the final equation, which shown the ith client weight change between the F input F hidden layer neuron and the nth output layer neuron, that is equal to a eta, that is the constant, and the learning rate of the client I, because every client have the different learning rate. Normally we choose the value between 0 to 1, but not equal to 0. In our case, we normally choose 0.5. You can also use fuzzy to adopt these learning rate, but in this application where I apply, so we fix the learning rate, which is a 0.5, and W's the weights of that one, which is shown in previous as well. Okay. And similarly, we also need to update the weights between the input and hidden layer, which represent with A. So when we're talking about the back propagation, first we update the weights between the output and hidden layers, and then based on that, we update the weights between the hidden and input layer neurons, so which is represented with the change in A. So these are the final equations which we can use to update the weights between the output and hidden layer, which is represent the B, and similarly the A's equation, which is represent the weights change between the hidden layer and the input layer neurons. So this is the pseudocode which we execute at the client side. In here, you see there that there's the data, and we have the weight we initialize the weight matrices of the input and hidden layer. And similarly, I mean input, H mean hidden. Similarly, B ith client, h mean hidden and o mean output, the weights between the hidden and output layer neurons. Then we split the data into a multiple small groups. Then we initialize the weights, and then we apply the feed forward using the previous equation as I shown, that calculate the x and w, then we calculate the error, and then back propagation with the help of those we update the weights, and we execute this one until we not meet our stopping criteria. Stopping criteria can be a number of cycle, it can be your accuracy, it can be a minimum mean square error, it can be anything, is depend upon you. And then once it meet their optimum goals, it's converge, then it return the two things, the optimum weights between the input and hidden layer neurons, that is a matrix actually, and second matrix, which is the between the hidden and output layer neuron, which is represented with the B's. So this is the pseudo code which we execute at the ith client. Now we're talking about the server side. When we're talking about the server side, in here I just choose the 3 clients for understanding purpose. Just we choose 3 clients. So client 1, client 2, client 3. So in here we use in client end you can use different algorithms. So actually we use the 3 different variants of the neural network for each client, which is LM, BR, and S scale conjugate SC. So in here you see that in first client the weights between input and hidden layer, the dimension is D1, D2. And similarly, because every client have different dimension, it's not mandatory each client have the same dimension matrix. It can be a different. So that's why we use the different variable D1, D2. But when we're talking about the client 2, where we use the BR algorithm, the weight matrix between input and hidden, that is a D3 and D4. And similarly for the third client, the dimension of the weight matrix which is returned, that is the D5 and D6. Now there's 2 cases. Number one, if the number of rows and number of columns of each matrices are the same, so then it's very easy to make the aggregate model just to add. That's one of the formula. Okay, you just add these matrices and make the aggregate model of the federated server end weights between the input and hidden layer. But if these dimensions are not same, you know that if the matrix A number of rows is not equal to a number of rows of second matrix, you cannot add the matrix. Then you need to zero padding. So if there's a multiple method, you can dimension reduction you can use and so on. So in here we just add the zero padding. So in here just we calculate the maximum number of rows and maximum number of columns. Then according to that we make the zero matrices and we concatenate those zero matrices with our actual matrices. And once we concatenate these one, so their matrices dimension are same. Definitely when we add the zero concatenation, the computation complexity is high. So for modified version of this one, we use the dimension reduction and we also reduce the complexity. But in today's session, we just explain the zero padding. Definitely that is the computation complexity is high. Then and this is a variant of my other algorithm, which is called a weighted federated. In here, we not give the same weights to each client, because maybe one client have the 1 terabyte data, or maybe a second client has only 1 GB data. So your model which train on 1 terabyte have the extract the more feature, have the more learn more properly as compared to second one. So we give the more weightage to that one. Maybe there is some client which we have the binary classification or ternary classification. In that case, maybe a one client have only few sample of the class 1, but it's a large number of sample of class 2. In especially in medical cases, if you're talking about the cardiology hospitals, so if you're talking about the Lahore maybe adults, a child, every type of the patient are there. But if you're talking about the Faisalabad or some Peshawar, maybe there's some child cases are less, but their male cases are more than that. So we and number of patients is also less. So according to that data and their accuracy and those things, we give the weightage of each algorithm in each client. In here, I use second client is a 2 times weightage, and a third client because during simulation when we execute this one, the third client has the lowest data. That's why we give the smallest weightage to that one. And using these formula, we calculate the input and hidden layer weights of the federated server end, and similarly the weights between the hidden and output of at the server end, which is represented by the BHOFS. After calculating this one, as I mentioned earlier, in here you can use any algorithm, but I use the feed-forward neural network. So that's why this pseudocode and mathematical model is also represented with the neural network. So in here, once we receive each client weights, then we calculate BHFS, which is shown in previous slides, and FS. Then we need to calculate before in client end, I use the sigmoid activation function because my problem is I told you that the sigmoid activation function is mapped. So that's why server end I also use the same activation function. So if in here you use the tan hyperbola or maybe a ReLU activation function, which give the any real positive number or you scale down up to your problem. So the same one you use in here. Or in here you can use some other algorithm, GAPS, so it's up to you for the prediction purpose. In server end, there is no learning mechanism. This is a very important. Just feed forward mechanism is there. There is no learning parameters there. Okay, now we are talking, this is the mathematical model which we simulate and obtain the results. Now we're talking about the real-time application. So in here, we apply this algorithm in first time I use this in our one of the real-time funded project in Gaussian University is the hydrogen storage. This is a collaboration of our chemical department, which collect the data from the real-time applications and this mathematical and I propose from computing department. I propose a solution from the AI domain of federated learning. So in here, this is the real-time operators where we can collect the data. After collecting the data, just we perform some pre-processing. After pre-processing, we use three algorithms as I shown in the previous mathematical model, LM, BR, and scale conjugate, and then we'll train the model until we not achieve our required goals. Once we achieve our required goals, then we make the federated server mathematical model, we implement that one, and after that we store that model into a cloud or in your local server, and then in real-time application you just collect the data and give it and it predict. So in this application we have the three type of the users: home users, then industry users, and our service stations. Yes,
Dr. Adnan Sahab,
yes, quickly.
kindly, it's a request, conclude कीजिएगा.
Okay, sure. These are the results of my first application, which shown that there's a accuracy, just like our accuracy, we achieved 96.4% and the misclassification 3.0. And second application is a smart health. I quickly, we collect the 4 hospital data and we aggregate model and we predict it. Just like this is a detailed model of that one, just a skip. This is the accuracy of the each client and because we have the 4 client, the 4 client training accuracy is 93, 94, 97, 95, and validation accuracy the client side is a 95, 93, 96, 94. And when we're talking about the aggregate model, proposed federated model, which is shown that is the 97% accuracy we achieved at the server end. And this is this is also published in CIBM journal, which have the more than 6 impact factor. And the first paper, which is published in engineering journal, which is applied energy, which have the more than 8 or 9 impact factor. Okay, and this is clearly showed that the proposed model achieve the more accuracy as compared to previous published approaches. There's other application area as well where you can apply the federated learning, like cybersecurity, smart traffic wireless network, and smart agriculture, and so on. Thank you. If you have any question, you can ask.
Any question? Audience? Some question here.
Thank you, Dr. Now we are going to move to our next presentation. Our next presentation title is Demonstrating Growth Using Technologies from Network Architecture to Real-World Application will be presented by Dr. Mohammad Azhar Khan. Dr. Mohammad Azhar Khan is an Associate Research Professor in Electrical Engineering and Prince Mohammed bin Saud University, Saudi Arabia. He holds a PhD in Electronics Engineering and University served as Associate Professor and Head of Electrical Engineering at University, where he led successful research about education. Dr. Khan has published over 50 articles in top journals, including multiple IELTS publications and focused on advanced for professional universities. It was ranked among Stanford University top 2% scientists in 2023. He has also received from the university's Best Researcher Award for 3 years.
Assalamualaikum everyone. Can you hear me? Please, can you feedback? Can you hear me?
Yes, sure. Yes, sir.
And my slides are visible?
Yes, please click on slideshow.
Okay, thank you. Okay, thank you very much for inviting me. I'm very thankful for inviting me to this STEAM conference. My topic is advancement in drones UV technologies from network architecture to real world applications. I kept my presentation very general to make fundamental understanding about the topic. So if someone is interested to start any research in the drones direction, so this presentation would be beneficial for them. The contents of the presentation is initially I will about the speaker. General overview about the speaker, drones fundamentals, taxonomy, hardware stack, design parameters, and from parts to a complete UAS system, network architecture, and then some case studies, key challenges, and then I will focus on the cybersecurity aspect. And then if someone is going to start some practical hands-on on the drones topic, so there will be some practical starter kit and then summary and takeaway. About me, I'm Muhammad Asghar Khan, and I'm currently Associate Research Professor at the Department of Electrical Engineering, Prince Muhammad bin Fahd University. About my publication record, I publish more than 130 plus publications in leading journals. I'm currently working as a data and reviewer for some esteemed journals like IEEE Transactions. I'm top 2% scientist from 2023 to 2025. And I got Best Researcher Award from Hamdard University, Islamabad from 2021 to 2023. And my research focus is generally on the network architecture of POVs, IUDs, SWAM, to propose some security framework for drones using hyperelliptic curve cryptography, elliptic curve cryptography, post-quantum cryptography, blockchain, and federated learning. So I will start from the basic, what basically drone is, and which is also called unmanned aerial vehicles. So unmanned aerial vehicle is just like an aircraft. They can operate without a human pilot. So you can control through RC, and it can be autonomous using mission controllers and some GPS navigation systems. So drones are basically a buzzword these days, and everyone is integrating drones and real and commercial applications. If you see, we see drones in many applications. Previously, drones were used for military application. Now it is being used for commercial and business application. Have you seen the drone market? If you see, it's going and surpassing around 150 billion by 2023. Initially, if you see, and this time the drone market size is around $73 billion, but it's going to surpass and can be reached up to $163 billion. So, more focus is to use drones in commercial and civilian applications. And this data is for the commercial and civilian drones. The focus is not for the military drones, because military drone is, another research topic, and it's very expensive. If we compare, there are multi types of drones. We have a multi-rotor drones, fixed wing drones, single rotor drone, fixed wing hybrid vertical takeoff drones. Multi-rotor drones are the most common drones we usually see in our daily life. People use this for aerial photography, surveillance, and inspection. These are very used for the shorter flight time and limited payload capability. They are stable, and it can be used for the daily life application. Someone can use this for the aerial photography. It can be used for the inspections and for surveillance purpose. Then we have a fixed wing drones. If you see, these drones are nowadays, everyone is talking about the fixed wing drones, and this one is used for the military applications. The fixed wing drones need a runway or launcher. It cannot hold just like a quadcopter or a fixed wing drones. And these drones can be used for, if someone want to use these drones for the commercial purpose, so it can be used for mapping, serving, long distance monitoring. But the primary focus of these drones is to use these drones for the military applications. Then we have a single rotor drones. This drones is just like a helicopter, but this can be used for the heavy payload delivery, and it can be used for the LiDAR mapping. It's basically a mechanically complex, and it can be used for the longer flight time. And this drone is a fixed wing hybrid vertical takeoff drones. And nowadays, these drones are being used by the Amazon, and it can be used for the long range and for the vertical takeoff and landing capabilities. It's basically, these drones are very expensive and complex to design and maintain. So these are like the commonly used drones we see mostly the quadcopters and these drones are used for more for the civilian applications. In these, the fixed wing drones are commonly used for the military applications, and single rotors, I mean, for the high payload use. And this hybrid are being used for the business purposes, mostly the Amazon, and they use for the hybrid drones. And we see the internal components of a drone if someone take a quadcopter. So these are the internal components of a drone's internal gadgets. The main important components is the flight controller. The flight controller is just like the brain of the quadcopter. It can be used, or we can say the brain of the drones. Flight controllers are many type, and we have a APM 2.8, and now the most commonly used flight controllers is Pixhawk. And flight controller is basically used to connect all the onboard components, and it can use to read all the sensors and the IMU and the gyroscope installed on board to the drones. Then we have a propeller. It is rotatory wing drones, and we have some motors, and if they are rotatory wings drones, and we have a power distribution unit to equally distribute the power amongst the onboard components. We have a battery on board. We have a first-person view camera. So, I mean, this is a basic, a drones is equipped with these basic components. Either if someone want to make a customized drone, so they can add more sensors and more gadgets as per their requirements. Flight controller, and we have a gyroscope, accelerometer, barometer, and GPS for navigations and for navigation purposes. And how these Pixhawks is connected with all these motors, and with the ground controller, and with the ground station RC, and with the telemetry with the receiver compass. So you can connect all these components to Pixhawk. The design parameters for a drones, someone want to, what should be the design parameters of a drone? So, we need to look towards the aerodynamics of a drones. You need a speed. Your application is a high speed application. If someone want to use drones for the ambulance services, so definitely he or she need to consider speed. And if someone want to use drones for the delivery purposes, so the first important parameter would be the payload. For communications, for the navigation, if someone want precision navigation, so definitely these are the design parameters. So, drones can be controlled through the remote control. We generally see a person holding a remote control and controlling the drone, but drone can be used autonomously, and the drones can perform multiple missions without involving any human on board on the ground. So for this, there is a very basic. For the ground station, someone need to install the mission planner, if he is using Ardo Pilot. And if someone is using PX4, so definitely Q ground controller can be installed on the laptop or any ground station. And then you just define all the missions and the viewpoints on those ground controller, and then upload the mission on the MV link on the drone. And then drones perform the mission on flying over those defined viewpoints, and then return to original position. So drones can be controlled through remote controller. It can be autonomous, performing all the mission autonomously without involving any human on operator. Drones is not an individual device which can a standalone device, but drone system is basically a combination and integrated ecosystem with air, ground, and communication components that work together to achieve stable flight, mission execution, and data transfer. So the sensor is basically used to collect real-time flight data. Drone control system is used to send command and mission parameter, then communication links for the transport telemetry and video data, and software that is the firmware installed on the drones. And the firmware can be in the form of Ardo Pilot, and it can be a PX4, which define which kind of flight controller someone is using. If we compare the network of the drones, so we can connect multiple drones in ad hoc mode, which is called flying ad hoc networks. And if someone's, want to deploy for the shorter lifetime, and for those areas which don't have any infrastructure facility or communication facility, so it can be deployed in the flying ad hoc network mode. And if there is missions beyond line of sight missions, so it can be integrated with the satellite and using the high altitude platforms. And drones can be connected simultaneously with the normal cellular networks. It can be connected with the cellular base stations. So drones, standalone drones has very limited capabilities, but if drones are connected in a network form, so it can be used for diverse applications and for the large scale applications, just like for the monitoring, for the crop, for the traffic, for the cattle, and any multiple civilian and commercial applications. So, I mean, drones, how we can connect drones. Sometimes we see that drones are connected through remote control. And on the other side, we see that drones travel to 1,000 kilometers and they perform some missions in different countries. So definitely they need to, they need to be connected with the satellite communications. So drones can be connected with satellite communication. For that purpose, for the backhaul link, we use geostationary and the LEO and even the MEO satellites, and it can be connected for the larger coverage. If in an area where there is no infrastructure and there is no terrestrial network, so we can connect different drones in the NTN form, the non-terrestrial network form. So we need to consider different drones at different layers, and then those aerial layer, these are the aerial layer, this is the space layer, and then we can divide into a terrestrial layer. So for the corridors and for those area which, I mean, in the desert where there's no infrastructure and or the sea, oceans, we can use the NTN network and the drones can be connected in those areas. For the case studies, it can be used for the infrastructure inspection where the KPI can be coverage and defect detection rate, safety incidents. It can be used for the precision agriculture, and the KPI there is the area per day and yield uplift proxy. And it can be used for the public safety and disaster response. And the KPI there is the time to flight view, communication uptime, and target reacquisition. It can be used for the logistic and last mile delivery, and the KPI there is the delivery success or cost per stop. Okay, these are the basic overview about the drones. What basically drone is, what are the internal components of the drones, and how can we connect drones. It can be a standalone, it can be in a network form connected to the satellite communication, it can be deployed in the ad hoc mode in the form of flying ad hoc network. But if we see drones, so drones are basically resource constraint. So I mean, you cannot drones on the own would have limited processing, limited battery power, so it cannot execute complex mathematical operations. So on the security perspective, what my area of research is, I propose a lightweight security mechanism, and the lightweight security mechanism are basically in the form of hyperelectric curve cryptography. This is somehow a public cryptography. Previously, the RSA was used, ECC, electric curve cryptography were used for the lightweight cryptography mechanism, but hyperelectric cryptography is the most feasible options for the security of drones, because the hyperelectric curve used an 80-bit key size, providing the same level of security as RSA bilinear pairing or ECC were providing. So in a paper I published, I used hyperelectric curve cryptography for the UAV's network, and the computation times were 0.48 millisecond for the signing and 0.48 second for the verifying phase. And the second important thing is the communication costs were also reduced, and it was around 16 bits. So, I mean, the hyperelectric curve cryptography, I mean, if someone want to use, I propose cybersecurity algorithm for drones, so hyperelectric curve is the most feasible options for drones, which can be used. No, I mean, I want to conclude my presentation. I kept my presentation very general. If someone want to start from drones, so what drones can be, how someone deploy a drone. A person need any kind of drones, and if someone want a high precision, definitely you need to choose a drones installed with Pixhawk flight controller. And if he's using autopilot Peaks for ROS can be installed. It is compatible with drones, and someone need to work on the mission planner, Q ground controller, and the application checklist should be, I mean, the logs, training, permission, and simulation before flight. So there are some simulation software which can be used for the drones flight before practically deploying the drones. On the architecture views point of view, if someone want to see and someone want to deploy drones, so it can be in ad hoc mode in the form of flight ad hoc network, and the NTN form, it can be connected with the non-terrestrial networks integrated drones with the satellite. In the same times, for the safety and for the future, if someone want to use a highly secure drone system, so definitely he and she should think about the post-quantum cryptography algorithms, because the conventional cryptography algorithms were broken by the by Shor algorithms. So definitely for the future perspective, post-quantum cryptography is the most feasible options for the security and against the quantum attacks. So, I mean, this was a presentation on my side. If there's any questions, so you can ask question.
Dr. Zainab, kindly unmute your mic.
Hello,
Yes.
can you hear me?
Yes, ma'am. Assalamu alaikum, Dr. Zainab.
Hello.
Ji, kindly proceed your presentation, Doctor.
Hello, can you hear me?
Yes, ma'am. Dr. Zainab, can you hear
Okay.
me?
Yes.
Okay,
Assalamu
kindly.
alaikum everyone. Okay. Can I start?
Sure, ma'am, sure.
Okay. Assalamu alaikum everyone and a very good afternoon to all of you. First of all, I would like to thank the organizer for the kind invitation and for giving me the opportunity to share my work with you. So today I'm going to talk about a machine learning model that we use to predict the HLA binding peptides that are involved in drug adverse reaction. So first of all, I will talk about what is HLA and then the role of HLA in drug adverse reaction and why we use the machine learning for the prediction of HLA binding peptide. So the HLA is a complex of genes that enable our immune system to detect and respond to pathogen, viruses, and even the cancer cell. HLA only occupies 0.13% of the entire human genome. However, within this small region, it contains more than 200 genes that are known to be associated with 3,000 complex diseases and adverse response to more than 163 drugs. HLA is also known as major histocompatibility complex, and it is divided into four main classes: HLA class 1, class 2, class 3, and non-classical HLA gene. So the HLA molecule are located on the short arm of chromosome 6. The key molecule of HLA class 1 is HLA A, B, and C, whereas the key molecule of HLA class 2 is HLA DR, DP, and DQ. So this is the 3D structure of HLA class 1 and class 2 molecule. The HLA class 1 molecule contains one long and one short chain. The long chain is made up of alpha 1, alpha 2, and alpha 3 segments, whereas the short chain is basically beta 2 microglobin. HLA class 2 molecule contain two equal length chain, 2 alpha and 2 beta chain. So they are structurally pretty much different. The structure difference between HLA class 1 and class 2 molecule can be understood if you look them from a top view. Their peptide binding site is quite different. The HLA class 1 molecule can accommodate 8 to 10 amino acid long peptide, whereas HLA class 2 molecule can accommodate bigger peptide from 13 to 15 amino acid long. So HLA class 1 molecule only express on nucleated cell, whereas HLA class 2 only express on antigen presenting cells such as B cell and macrophages. The main function of HLA class 1 molecule is to present peptide to cytotoxic T cell, whereas HLA class 2 molecule present peptide to helper T cell. The HLA region is one of the most polymorphic region of the entire human genome. What I am showing here is the number of HLA allele that has been characterized and given name by World Health Organization. Until March 2024, the total number of allele was 30,000, whereas in September 2024, the total number of allele was 45,000. So just within 6 months, 15,000 allele variant increased. HLA molecule is highly medically relevant. The variant in the HLA region play an important role in different diseases such as infectious disease, cardiovascular disease, cancer, and autoimmune disease. HLA molecule also play an important role in drug adverse reaction, which is the fourth leading cause of death worldwide. HLA molecule is considered as a genetic marker for the prediction of adverse drug reaction. So these are the most well-documented cases of HLA-mediated severe adverse reaction, such as the association of B5701 with abacavir-induced hypersensitivity reaction. Abacavir is a FDA-approved medicine which is used for the treatment of HIV infection. B1502 is associated with carbamazepine-induced hypersensitivity reaction. Carbamazepine is an anti-epileptic drug which is used for the treatment of epilepsy. And this adverse reaction is mostly observed in Asian population, including Pakistani population and Indian population. The association, HLA 3101 is associated with carbamazepine-induced severe adverse reaction. 5801 is associated with allopurinol-induced severe adverse reaction. Allopurinol is used to lower the level of uric acid in the body. So for all these drugs, genetic testing is recommended by CPIC guideline before prescribing these drugs. CPIC is Clinical Pharmacogenetic Implementation Consortium. CPIC, FDA, and PharmGKB recommended the genetic testing for the drugs that are associated with the HLA-mediated adverse reaction. PharmGKB is basically a database which is which integrate the data from CPIC, FDA, and latest research studies. So it provides the gene drug summaries and the variant annotation. There are different level of evidence in PharmGKB. Level 1A is the high level of evidence that this particular drug is associated with adverse response. A previous study published in Nature, they identified that B5701 is associated with abacavir-induced hypersensitivity reaction, and they reported that normally HLA bind with a self-peptide and perform normal immunological response, but in case of abacavir, HLA bind with incompatible self-peptide and alter the immunological response, which lead to the development of Stevens-Johnson syndrome. Stevens-Johnson syndrome is due to the adverse reaction of abacavir, and this is a skin disorder. So here I am showing the latest review that highlight the diversity of HLA allele in different population. However, the data of Middle Eastern or Qatari population is missing here. This is the figure from GWAS catalog. As you can see the figure, a lot of the genome-wide association study is conducted in the European population. Moreover, if you will see the PharmGKB database, which is one of the largest pharmacogenomic database, 63% of the data is coming from the European population. So the Qatari population is highly underrepresented in the GWAS catalog and the PharmGKB database. So the association that were identified in the European population cannot be effectively implemented and translated in the Qatari population. So therefore, first of all, we conducted the pharmacogenomic analysis. Pharmacogenomic is basically the study of how our genetic variant affect the response to the drugs. So we use the whole genome sequence data of 14,000 Qatari population, and we identify the allele that are associated with severe adverse reaction. And we compare the allele frequency of those variants in Qatari population, and we compare it with other population that are available in CIWD database. So overall, we identify 102 pharmacogenomically important variant in the Qatari population. So this figure shows the comparison of the allele frequency of important HLA variant between Qatari population and CIWD data set. And we observe that the variants such as B5801 have high frequency in Qatari population as compared to CIWD data set, and this allele is associated with adverse response to allopurinol. A3101 also has high frequency in Qatari population, and this allele is associated with adverse response to carbamazepine. Moreover, we identified that C0302 also has high frequency in Qatari population. This allele is also associated with allopurinol. Finally, C0602 has a high frequency in Qatari population, and this is associated with adverse response to sulfamethoxazole. Sulfamethoxazole is also an FDA-approved drug, which is mostly used for the treatment of bacterial and viral infection. Then we compare the Qatari population and African American population, and we observe that the Qatari population has high frequency of A3101, C0102, C0302, and C0602 as compared to African American population. Then we compare the Qatari and Asian population, and we observe that Asian population has high frequency of C0302, C0102, B5801, B5701, and B4001. And all these alleles are associated with adverse response to different drugs. Interestingly, we observed that the allele frequency of A3101 is similar in both Qatari and the Asian population. Then we compare the Qatari population with Hispanic population, and we observed that the Qatari population has high frequency of B5801, C0302, and C0602. Then we compare Qatari and American population, and we observe that the American population has high frequency of B5801, C0102, and C0302 as compared to Qatari population. Finally, we compare Qatari population with the European population, and we observe that the European population has high frequency of C0102, B4001, B5701 as compared to Qatari population, whereas Qatari population has high frequency of C0602, C0401, B5801, and A3101 as compared to European population. Overall, from this study, we observed that The Qatari population, Asian population, and American population are at higher risk of developing the severe adverse reaction if they will take the drugs that are associated with HLA-mediated adverse reaction. So then we identify the HLA variant that are present in the individual who are already taking the medication. So in our cohort, we observed that the 7 individuals were taking methotrexate. Methotrexate is an FDA-approved drug used for the treatment of autoimmune disease and cancer. We observed that out of 7 individuals, only 3 individuals carry C0602, and this allele is associated with positive response to methotrexate. So if the individual will take this drug, they will not develop any type of adverse reaction. So we also observed that 15 individuals are taking Keppra. Out of 15 individuals, only 3 individuals carry A1101, and this allele is associated with Keppra-induced severe adverse reaction. In case of carbamazepine, we observed that 16 individuals are taking carbamazepine. As I previously mentioned, carbamazepine is an anti-epileptic drug. Out of 16 individuals, only 3 individuals carry B5101 and B5801, and these alleles are associated with carbamazepine-induced hypersensitivity reaction. Finally, we observed that 29 individuals were taking elafibranor. Out of 29, only 2 individuals carry the alleles that are associated with hypersensitivity reaction. Out of 2 individuals, 1 individual carry all the 3 alleles that are associated with adverse reaction. So this individual are at higher risk of developing the toxicity if he will take the elafibranor. Then we performed the molecular docking of pharmacogenomically important variant that we identified in the Qatari population to see the interaction between the peptide, HLA allele, and the drug. So overall, we use 58 FDA-approved drugs. This includes the anti-epileptic drug, antimicrobial drug, the drugs that used to suppress the immune system, anti-inflammatory drug, the drugs used for the treatment of cardiovascular disease, drug used for diabetes and metabolic disorder, drugs used for the treatment of cancer, and anti-thyroid drugs. So overall, we performed the molecular docking of 58 unique drug with 102 HLA allele and the peptide. This peptide is already reported that if this peptide will bind with the drug and HLA allele, it will cause different type of hypersensitivity reaction. So out of 58 drug, we observed that only 4 drug interact with the key residues in the F and A pocket of B5701. And these residues are involved in the development of severe hypersensitivity reaction. So these drugs are B5701, peptide abacavir complex, flucloxacillin, methotrexate, and ticagrelor. So the interaction of the abacavir with B5701 and peptide were previously reported. So they mentioned that in case of abacavir, peptide bind with F and A pocket of B5701 and cause different type of hypersensitivity reaction. So in case of flucloxacillin, we observed that peptide bind with the same pocket, F and A pocket, and cause the hypersensitivity reaction. The association of B5701 with flucloxacillin mediated drug-induced liver injury were also previously reported. Flucloxacillin is also used for the treatment of infectious disease. So we also observed that the methotrexate also, in case of methotrexate, peptide also bind in the same pocket, F and A pocket, and cause different type of hypersensitivity reaction. So moreover, we observed that in case of ticagrelor also allow the self-peptide, the same peptide bind with the F and A pocket and also cause the hypersensitivity reaction. So overall, from molecular docking, we observed that the peptide is very important for the prediction of different type of severe adverse reaction. So this study highlights the importance of accurately predicting which peptide can bind with specific HLA allele and cause the hypersensitivity reaction, because all the peptide cannot develop the hypersensitivity reaction, because normally HLA can only work when it will bind with the peptides. So in order to accurately predict which peptide will bind with the HLA and cause the hypersensitivity reaction, we designed a machine learning method. We called it PEP-HLA-I. So for this purpose, we use the data set of more than 1 million peptides. And for feature encoding, we use 3 different methods: dipeptide deviation from expected mean, extended pseudo amino acid composition method, and composite protein sequence representation method. All these 3 methods basically extract the physiochemical properties from the peptide sequence. For model training, we use MLP, ensemble voting, CAD boost, random forest, and XGBoost. The dataset that we use mostly contain the peptide belong to HLA-B and HLA-DRB. So this figure show the performance of machine learning model on the HLA class 1 binding peptide dataset. So as you can see in the figure, from all the model that we use, ensemble voting show the highest accuracy for the HLA class 1 binding peptide prediction. This figure represents the performance of the different machine learning model for HLA class 2 binding peptide. So this figure also shows that ensemble voting show the highest performance in terms of prediction of HLA class 2 binding peptide. We compare the performance of our method with already previously developed tool. Overall, we compare our tool with 30 different tools that were available in the market. And we observed that our tool PEP HLA-I show the highest performance as compared to already available tool in the market. So when we compare the performance of our tool with NetMHC Pen2, which is a widely used tool for the prediction of different type of peptides, we observed that our tool improved the accuracy by 32.5%. So overall, we observed that PEP HLA-I has the higher accuracy for the prediction of HLA class 1 and class 2 binding peptide. So we will also provide the publicly available web server soon. And we also observed that Qatari population, Asian population, and American population are at higher risk of developing the adverse reaction when they will use the abacavir, carbamazepine, and allopurinol. And we also, our tool can also be used for the prediction of the peptide that can be used for vaccine designing and also for the development of drug designing as well. Finally, I would like to thank all of you for listening.
Of security threats from various global challenges with future research direction. Dr. Safri, a senior member of IE, is a senior lecturer at the Institute of IE, Asia Pacific University of Technology and Innovation. He actively collaborates with several Asian universities and focuses on cybersecurity, blockchain, energy efficiency, and healthcare and Dr. Ali has published research papers
लगाए हैं कोडिंग सिंबल के बेहतर है
Hi everyone, Assalamualaikum. This is me, Dr. Itizaz Ali. Can you hear me right?
Yes, Dr. Itizaz, kindly just wait for 3 to 4 seconds for interview for introduction of.
Okay, sure.
Kindly continue, ma'am.
This research interesting use IoT, wireless network, and regular communication, and he also served as a guest lecturer for multiple years.
Okay, Dr. Itizaz, kindly can proceed your presentation.
Okay, Assalamualaikum and hi everyone. This is me, Dr. Itizaz Ali, senior member at IEEE, and today actually I want to present my research title is actually Internet of Vehicles, Security Threats, Countermeasure, Open Challenges, and some future research directions. So first of all, about me, my name is Itizaz Ali. I'm working in Malaysia as a senior lecturer, Asia Pacific University, Malaysia. Also, I'm working as a visiting professor in Monash University, Malaysia. I published more than 100 research papers, and mostly my papers are published in IEEE Internet of Things Journal, IEEE Consumer Electronics, and mostly transactions. My research area is actually blockchain technology, Internet of Vehicles, UAV, cybersecurity. I'm the reviewer of all of these like mentioned journal like IEEE. Also, I'm a guest editor of several journals. So this is the outline. So background, what is Internet of Vehicles? There's actually connected vehicles and there are different scenarios. But we will look into mostly to the security challenges because I'm more like toward cyber security and cryptography. So we know that nowadays these vehicles, they are connected through sensors, internet, and GPS. So the vehicles, they have different scenarios like V2V, V2I, V2X communication technologies. It's the combination of sensor, edge and fog computing and the cloud computing. So these are the combination which make it more complex, and so that's why the security is very important. If there is a security breach, it can lead to a severe problem. Yeah.
सर आपकी स्लाइड्स जो हैं वो चेंज नहीं हो रही.
Okay, again, let me share again, okay?
So please on slide mode.
Slide show nahi ho rahi, okay. Let me share, okay? Okay, just 1 minute. That's up, now you can see.
Yes, doctor.
Okay, now okay, start, right? Okay. So, okay, it's a combination of like a sensor, edge computing, fog, and cloud. The most important is actually real-time data exchange for safety and services. We also need to consider the most important thing is data, and data is everything. And we know that security of data is very, very vital and important. So when the vehicles are moving on the roads, actually the data exchange in real time, and that data is used for the safety purpose. So if the data is violated or if there's any security breach happens, so it can lead to a very big problem. So what are the Internet of Vehicle requirements? If we look into it, it's actually you can say an ideal model for Internet of Vehicles. So vehicles are connected, and we have encryption techniques, anti-jamming encryption. CSI means this is a channel state information, some hardware-based fingerprints, which is assigned to every vehicles, and physical layer security, secure code, and some neural security if we integrate the machine learning. So this is how it works in a real-time scenario, the Internet of Vehicles. So when the vehicles are moving, the data is exchanged, and that data is actually used for the safety purpose. So here is actually an overview of the taxonomy of Internet of Vehicles and enabling technology. How we can make the taxonomy of these enabling technology with regard to Internet of Vehicles. Yeah.
Your entire.
You can see, right?
Your slide not moving in during the presentation.
Now it's okay.
Yes, fine, but kindly change the mode. Slide mode पर कर लें kindly.
Okay. Sure. Now it's okay.
नहीं डॉक्टर साहब नहीं अप्लाई नहीं हुआ वो आप क्लिक तो कर रहे हैं उसको.
Please share the entire screen.
Okay. Let me try again. Dr. Sam, now you can see, right?
Yes, now fine. No, Dr. No, you're great. Please continue.
Okay. Okay. So this is actually the taxonomy, how we can make the taxonomy of these enabling technology with regard to Internet of Vehicles. So here we can see the edge layer technology on the first, which is the first layer. Then we have the communication technologies like a 5G router, connecting devices, connecting tower, IoT devices, and traffic lights, all these sensors. The last one is actually, we have the network cloud. So actually the data start from the edge layer to the communication technology, and then it approach to the network cloud where it is used for the processing purpose. So how this is called the taxonomy of enabling technology. So usually IoE architecture and components. So it's in vehicle network. In vehicle means how many vehicles can be combined to a network. Okay, as a simple network, mostly it's from 70 to 100. It depends. Onboard sensor and ECU. So ECU is actually electronic component unit, roadside unit like sensor, and edge node. So edge node are actually the server, the small server, you can say the lightweight server which are installed on the roadside. So these are the edge nodes. And then we have the cloud platform and services. So cloud, the data is imported to the cloud for the processing, and we can use like the machine learning technique, federated learning. We can use the encrypt like a homomorphic encryption to encrypt the data, and that data can be used for the processing. So security threat landscape. So at high level, we can see the eavesdropping and privacy leakage, spoofing and identity attacks, denial of service, malware and ECU compromise, and data integrity attacks. So these are the very common attacks which have more chances to be happen in the Internet of Vehicles. So security challenges. So we can see these enabling technologies and the security challenges associated with these, we can see the data compressions. So we can the artifact attacks, the standard and protocols. We can see the DOS attack, DDoS attack, the civil attack, the networking technology. If we look like number 3, the networking technology, here is actually we can see the false signal, authentication problem, access control problem. So these are actually the most important security challenges which need to be explored more deeply if we are actually working with the Internet of Vehicles. And we have more opportunities to work on and do research on these security challenges. Some of the open security challenges are actually, what are the open security challenges? Communication and interference challenges, physical layer security challenges, protocol development and evolution. When we the protocol develop, you develop the protocol, what are the actually security measures that need to be evaluated? Privacy and data integrity challenges and standardization challenge, and machine learning and blockchain challenges. Yes, a blockchain, we know that blockchain is decentralized, but there are also some security challenges. For example, the collusion attack. When a node predict try to show that this is a genuine and the node is not genuine, that is called collusion attacks. That's happened in blockchain. That's one of the attack in blockchain. Threat example and attack vectors: GPS spoofing, false traffic message, remote code injection into ECU, electronic component unit via infotainment, man in the middle on the V2X links, and RSU broadcasting false beacons. So these are some of the example. Risk impact, like safety risk, collision, wrong activation. It's happened. There are many examples of this, that what are the risks associated with the Internet of Vehicles when all the car are connected to the IP and internet. So what can happen? What are the security? Privacy exposure, like location behavior, economic loss and reputation damage. Yes, for example, if there's a company like BID or there's any company like Tesla, any you can take an example, and it happens, these accidents happen frequently, so it can have a very big loss to the reputation, actually very important for the company. Large scale cascading failures. So countermeasure, how to countermeasure secure communication. Number 1 is actually mutual authentication like PKI and certificates. Secure V2X protocol like IEEE standards. We need to follow these encrypted channels and session keys. And we can also use some other advanced cryptographic techniques like a post-quantum and homomorphic encryption, partial homomorphic encryption techniques that can be a very good solution for this. we can use an in-vehicle anomaly detection. This method can be actually embedded into the vehicle's system. Network-based IDS intrusion detection system, federated and distributed detection across vehicle and RSU. So mitigation techniques, if you look into this actually flowchart or diagram, we can see the mitigation techniques for the jamming, interference, eavesdropping, spectrum, traffic signaling. For the symbol and node capture, we can use cryptographic methods, behavior-based, secure key storage, key rotation, rotating the key can avoid these attacks like symbol attack and node capture. For the side channel attacks, we can use the masking techniques and the cross-layer authentication, noise injection, and insulation of the data. For the GPS spoofing, we can use authentication like access control, role-based, attribute-based access control. So all these advanced mechanisms can be used. Public key PKI, modifying signal features also can avoid this GPS spoofing. So attribute-based access control, as I show, and we have published recently, we have published 2 papers in IEEE transition on attributes-based access control with the integration of Internet of Vehicles, and those publications are available online. And role-based policies also can be used, but the most I will suggest and recommend attribute-based access control because it's more flexible and it can adjust the attributes. Role-based can be still can be compromised. Trust scoring for vehicles, we can assign some trust score to the vehicles. If a vehicle is trust score is more high, we can consider this vehicle is actually more trustworthy, and this node is actually have high score of trust. Revocation mechanism and all these. So this is a privacy enhancing technique. Secure software and hardware. We also need to look into the safety of the hardware and like a TPM technique. Trusted protocol modules. These opportunities is actually some of the direction that we can do research, like scalability of PKI and certificate management, real-time constraint versus heavy crypto, privacy versus accountability trade-offs, heterogeneity of manufacturers and standards, insider threats and physical access. The most dangerous is actually insider threats in a company or in a network. That's very, very important how to identify, and it's very difficult to identify the insider threats actually. So yeah, research direction. So I would recommend 2 research directions, protocol and cryptography. Research direction 1 is actually we need to research more on the protocol and cryptography, lightweight cryptography for low latency V2X. We need more lightweight cryptography. If we look into the homomorphic encryption, which is sometimes it's actually resource constraint, group signature, we need to use group signature, and efficient revocation, post-quantum readiness for the vehicle life cycle. Research direction 2 is actually detection and machine learning. So we need to integrate explainable machine learning for intrusion detection, which can provide more security and privacy in case of the Internet of Vehicles. Federated learning is a very good example and a very good research direction for vehicle with a privacy guarantee. Robustness against adversarial example. In conclusion, Internet of Vehicles bring transformative benefits but significant security risk at the same time. And there are some solutions that we have proposed. A layered defense combining crypto, IDS, secure hardware, and privacy technique is needed. Multidisciplinary research and industry cooperation is required. These are some of the actually references in the future reading, dataset and test bed, representative paper and survey. Also, I have many paper recently, 2 paper in a transaction. You can search my name in that. You can find those paper. If you need, I can. And this is my actually email address for any research collaboration. We are open to have research collaborations. Yeah, and we also have provide funding for research. Thank you so much, ICOSST and the team, and especially to Dr. Nadeem and Dr. Tariq. Thank you so much. If any question you can ask.
Bundle of thanks, Dr. Etazaz. Your presentation was excellent. And
Thank you so much, sir.
thank you.
Thanks.
बस इसकी जरूरत नहीं आना से अब मैडम